Alright, let's get started with Module 12 here, where we start talking about rational expressions. We've already learned about polynomials, um, and so that vocabulary helps us out a little bit with rational expressions. What a rational expression is it's basically a fraction. You could think of that you have a numerator and a denominator, and you're going to have a polynomial here and a polynomial here, um, or sometimes you might even think about a constant in one spot, but I guess you could technically classify a constant as a polynomial also of degree 0, but maybe they look something like this. You might have one that just I'm just making this up off the top of my head, where you have a trinomial over a binomial. That could be one example of a rational expression, but there's many of them that we'll see in this module, okay? And so the things we'll do with rational expressions are we're going to simplify them or reduce them, kind of like we did with fractions. We're going to add, subtract, multiply, and divide these, okay? And then we're going to also evaluate, and that's where we put a value in for the variable, and then we do some computing, okay? So how is a rational expression different than a rational equation? Well, a rational equation, this word here clues us in that there's going to be an equal sign. So if we look at the rational expression that we had above, and we just write it down, but then put equals something, okay? And it could equal a number, or it could equal another polynomial, but I'll just put equals 6, okay? And then what we'll do with those rational equations is we're going to solve those rational equations, okay? So what are some things in mathematics that leads to the statement of undefined or non-real solution or domain error, okay? Well, this is going to lead us into the topic of problem number 2 here in 12.1. But one thing that causes us to get an undefined result in mathematics is when we divide by 0. So division by 0 is one thing that can lead to an undefined answer. Another thing that could give us a non-real solution would be something like this, where we did the square root of -25. We'll get to that in a little later module, but that would yield an imaginary solution. And then some other things that involve logarithms that could lead us to these types of solutions also. But the main thing we want to focus on right now is this division by 0, that we get an undefined result when we divide by 0, okay? So let's do these first two problems from 12.1 and see how we're doing on time in this video. But this is where we're going to evaluate, and they give us a rational expression here. They give us a value, which this one's pretty easy. They give us a value of 1, so we'll put 1 in wherever we see an m. So we have -4 times 1 plus 5 over 8 times 1 squared plus 4. Okay. Remember, we take this and we basically could draw an arrow. We're going to put that right in wherever we see an m. Okay. And then we'll do our computing here, and we get -4 plus 5 over 8 plus 4, and we get 1/12. All right, now looking at the next one, a little more complicated because we have a negative number we're substituting in, and we have to be a little more careful with negatives here. We're going to have 15 times -7. I'm just going to write the input value in red this time, minus 2. Then I'll have -7 squared minus 3 times -7. So we're putting that negative 7 in wherever we see our variable. And then minus 4. Okay. On top here we get negative 105 minus 2. I think I multiplied that correctly. We get careful on this. It's positive 49. This here is positive 21. And then we have minus 4. Okay. So on the top of this fraction, or the numerator, we get negative 107 from putting these two together. And then we get 70 minus 4 is 66. Okay. And that's fine. We don't have to put that as a mixed number. We just leave it as an improper fraction. Okay. All right, that's a good start to 12.1, and we'll look at stating restrictions in the next video. All right, thanks a lot.